In the environment, in power plants, factories, on the roads and in the home, there are some sensors that wait for long periods to detect sudden, short and sometimes very faint events, as shown by the examples here. The aim of this video is to show how these particular types of sensing with long waiting times can be made less power hungry in order to extend their battery life. A sensing device uses power to do two things: listen and react. Both require power. The sensors we are looking at here use most of their energy to do the listening. An extreme example, just for illustration purposes, would be a seismic damage sensor that listens for a quake for years, recording multi-kilohertz sampled acceleration and processing essentially useless information, and then reacts by recording the tremor that lasts just a few seconds so that the safety of the structure can be analysed. In this example, almost all of the energy has been used for listening. This video shows how to eliminate this listening power. In fact, here we have picked out some of the sensing examples where long waiting times are involved and where sensors should ideally be kept alive and listening all of the time. Keeping these devices alive requires power to carefully time listening and sleep modes. This drain represents a significant energy demand that depletes battery life and is wasteful. There are economic and environmental advantages in eliminating keep-alive power drain. In response, our team at the University of Bristol, with government support, have developed a method of eliminating keep-alive power drain, using minute, insignificant quantities of energy from the event that the device is waiting for. This energy switches on mains or battery-powered devices exactly when needed. This voltage detector chip uses over 1,000 times less energy than existing detectors. 5 picojoules of energy and only around half a volt are enough to create a turn-on signal. This is so little that many sensors can provide this without requiring a power supply. Now, with no power being used from the battery, the system is alive and listening. So we can stop using power for listening, sleeping, timing, receiving, etc., and save our battery for reacting to events. This patent-pending voltage detector, or keep-alive device, is a low-cost chip that is small enough to fit into many autonomous electronic devices. You can find datasheets for the chip and evaluation boards on our website. There are a number of application areas where it is beneficial to reduce the keep-alive power drain to zero. Mains-powered equipment, where savings for consumers and the environment are made. Battery-driven sensors and monitoring systems, where the long-term reliability and battery life are increased and the size decreased. Remotely powered sensors, as these can be made smaller by reducing battery capacity. It also reduces the power needed to remotely control these devices. The sensitivity of the voltage detector also allows the elimination of mechanical switches. Our website has demonstration videos of zero-power sensing using this chip. If you think your product or project might be better if it had no keep-alive power drain, then please get in touch or request samples via our website.